Hey, P statistics. So in this third part of section 12.1, we're going to go ahead and perform a significance test for the slope. And so we're going to follow our standardized test statistic is equal to statistic minus parameter divided by standard deviation of statistic format, or standard error of statistic, really. And so in this case, we're going to perform this type of test. So suppose the conditions for inference are met to perform a test of the hypothesis that beta 1 equals some hypothesized slope. And a lot of times this will be 0. So is the slope significantly greater than 0, significantly less than 0? That's how often this will go. Compute the standardized test statistic by doing t is equal to our sample slope minus the hypothesized slope, which might just be 0, divided by the standard error of the slope. That same standard error we calculated in the last section, and it shows up in the computer output. Find the p-value by calculating the probability of getting a t statistic this large or larger in the direction specified by the alternative hypothesis, h sub a, in a t distribution with degrees of freedom is equal to n minus 2. So, example problem here, we're going to go through the full significance test. Infants who cry easily may be more easily stimulated than others. This might be a sign of a higher IQ. Child development researchers explored the relationships between the crying of infants 4 to 10 days old and their later IQ test scores. A snap of a rubber band on the sole of the foot caused the infants to cry. So they hit them with a rubber band and make these children cry. The researchers recorded the crying and measured its intensity by the number of peaks in the most active 20 seconds. They later measured the child's IQ at age 3 years using the Stanford-Binet IQ test. The table contains data from a random sample of 38 infants. And so we got here how much they cried when they were snapped with a rubber band as a baby, and what their IQ was. And so then we do a regression analysis, and so we got all this information. We got our computer output, we've got our least squares regression line, we got our residual plot, and we got our plot of our residuals. You can do all this on your own, but more than likely this stuff will be given on a test, so you don't have to do it yourself. Seems like there's maybe a linear relationship. It's definitely kind of weak. The residuals look fine. The residuals seem to have a a normalish distribution, and so that condition seems fine. So we'll go through and kind of do this whole process. So first step, we're going to state our hypotheses, and ultimately the question being asked here was, they gave us all the output. Do the data provide convincing evidence at alpha 0.05 level of a positive linear relationship between cry count, peaks, and IQ in the population of infants? So they're trying to see if it's positive, which means it would be greater than 0. So our null hypothesis in this case is that the slope is 0. Our alternative is that the slope is greater than 0, where beta 1 is the true slope of the regression line, y IQ score to x cry count peaks in the population of infants. So make sure you indicate somehow that it's a population true slope, or the actual slope of the regression line for the population using alpha 0.05. So then we go into our plan. So this is a linear regression t-test, or t-test for the slope. And liner. So first, is it linear? Scatter plot looks okay. The residual doesn't show any curve. So yeah, it seems like the linear model is appropriate. Independent, we have 38 is less than 10% of all the infants, so we can treat it as independent. The normal condition, the plot of the residuals, shows no strong skewness or outliers. The C equals standard deviation. We don't see any real spreading or converging. A fairly equal amount of scatter around the horizontal line there, so equal standard deviation. And then the random condition, we have a random sample of 38 infants in this case. So conditions are met. So then we're going to perform this test. Our t-test statistic, actually, we can get just from the computer output, 3.07. We could do it on our own, so we could do our sample slope of 1.49 minus 0 divided by this. So if you actually just take this one divided by that one, you get this. So it does work out to be about 3. And so that is our t-test statistic. And then actually our p-value would be given here, but the computer output always gives a two-tail p-value. and we wanted one tail. We're doing just a greater than test, so we actually will cut that in half. Usually we double our p-value, so if we do like TCDF, we double it to get a two-tail. In this case, you can actually just cut that in half, and that ends up being our p-value, 0.002. So yeah, note because the p-value is for a two-sided test, and there's evidence for the alternative, we cut the p-value in half. So yeah, in this case, the sample slope was greater than 0, so that's why we couldn't know that we're cutting that in half for that tail. Because that tiny p-value of 0.002 is less than alpha, we reject the null hypothesis, and there is convincing evidence for a positive linear relationship between the count of crying peaks and IQ score in the population of infants. This isn't just chance that we got a positive relationship that was that strong. This isn't particularly strong, but it's not just chance, is what we could say here. We could then follow this with a confidence interval for the actual slope, the actual relationship. For predicting IQ from cry count. Of course, there's a calculator version of this. You can do linear regression t-test in your calculator, just have the data in L1 and L2, choose a direction, and pretty much just hit go from there. Another weird thing here is this is beta. It refers to beta, and this is actually rho, which is the true correlation. So that's kind of interesting to think about, that if the slope is positive, that means the correlation is positive. If the slope is negative, the correlation is negative. So you can actually do a test for correlation using the same kind of logic. In the end, you get the t-test statistic, the p-value, degrees of freedom, which I forgot to mention there is n-2, and you could have done that through TCDF if you had to. But it's not likely that you will. And so that is the significance test for the slope.